Hello, algebra students. We are on video number 29, and this is on page 11. So page 11, video number 29. Okay, so the type of factoring we're going to get into today is called greatest common factor. So number one says, for each of the following set of monomials, find the greatest common factor for each. So when I'm talking about the greatest common factor, I'm looking for the highest number that I can divide both terms by, or all three terms, or however many terms it is that you have. So in A, I have 12x to the third and 18x. So I'm going to write out all the factors of 12. So I know that 1 times 12 will give me 12. I know that 2 times 6 will give me 12, and 3 times 4 will give me 12. I know my factors of 18. If you don't know your factors, you're just going to take this number and divide it by your numbers until they start to repeat. So if I did 18 divided by 1, I would get 18 as my result. If I did 18 divided by 2, I would get 9 as my result. If I did 18 divided by 3, I would get 6 as my result. If I did 18 divided by 4, I would get a decimal, so 4 is not a factor of 18. If I did 18 divided by 5, I would get a decimal, so 5 is not a factor of 18, and then we're back to 6. So here are my factors of 12, my factors of 18. I'm looking for the greatest common factor. So the highest number these two have in common is 6. So my greatest common factor of my numbers is 6. And then I want you to write up at the top of your paper, I want you to star and write for variables, the GCF is the lowest exponent. Okay, so when you're looking at variables, the GCF is the smallest or the lowest exponent. So if I take a look back at A, we had x to the third power and just x. Remember, your invisible exponent here is 1. So the smaller of the two would be x to the first. So my GCF of these two terms is 6x. All right, we're going to do the same thing we're going to jump to E. So if I look at E, I'm going to write out my factors of 20. We don't need to worry about the negative so much. We're just going to keep it a positive 12. And then the factors of 28. So my factors of 20. 20 divided by 1 would give me 20. 20 divided by 2 would give me 10. 20 divided by 3 would not work evenly. 20 divided by 4 would give me 5. 20 divided by 6 would not work evenly. 20 divided by 7 would give me a decimal. 20 divided by 8 would give me a decimal, as well as 20 divided by 9, and then we're back to 10. We just listed our factors of 12 up at the top in A, so I'm just going to write those factors again. And then we're going to write our factors of 28. So my factors would be 1 and 28, 2 and 14. 28 does not divide evenly by 3. 28 divided by 4 would give me 7. And then we're back to the start. So here are my factors of 28. So if I want the greatest common factor, so they all have a 1 in common, or I would start at my highest number. So they don't all have 28. They don't all have a 20. They don't all have a 14. They don't all have a 12. They don't all have a 10, or a 7, or a 6, or a 5. So the greatest common factor of these three would be 4. Now they all have a variable. They all have the same variable. So that same variable is x. I want the smallest or the lowest exponent. So I have x to the third, x to the second, and x to the first. The lowest or the smallest is just x. So my GCF there is 4x. All right, we're going to skip to part C, or letter C, 1C. All right, so C gives me 21 and 14. So my factors of 21 are 1 and 21. 2 doesn't divide evenly. 3 would go in 7 times. 4 doesn't work. 5 doesn't work. 6 doesn't work. And then we're back to 7. My factors of 14 would be 1 and 14 and 2 and 7. So the greatest number that the factors have in common would be 7. This time, they have an x and a y. So since both terms we have x to the second power here and x here, remember we're taking the lowest exponent or the smallest exponent, which is x. And they also both have a y, so we kind of treat these separately. So the smallest exponent with my y, I have y to the 5th and y to the 7th. The smallest is y to the 5th. So my greatest common factor would be 7x y to the 5th. All right, we're gonna jump down to number 2 now. Number 2 says to write each polynomial below as a factored expression using the greatest common factor of the polynomial. So if I take a look at A, they give us 6x plus 3. So first I want to find my GCF, or my greatest common factor, of my numbers. So I have my factors of 3 are just 1 and 3. My factors of 6 are 1 and 6 and 2 and 3. So the greatest common factor there is 3. So what I'm going to do now is I'm going to write the 3. And then I'm factoring, right? So what that means is basically you're doing the opposite or the reverse of the distributive property. So when we distribute, we multiply. So now what I'm going to do is I'm going to divide both terms by that GCF. X wouldn't be in my GCF because the 3 doesn't have an x. So 6x divided by 3 would give me 2x, and then 3 divided by 3 would give me 1. What's nice about factoring is that you can check your answers. So if I redistributed that 3, so if I distribute 3 here, I would get 3 times 2x, which is 6x, and 3 times 1, which is 3. Did I end up what I started with? Yes, so that means I factored correctly. So this right here is your final answer. That is your factored expression. All right, if we take a look at D, we're gonna go to D now. So I have two numbers. My numbers are 10 and 15. So I'm gonna find the greatest common factor of 10 and 15. So my factors of 10 are 1 and 10, and 2 and 5. My factors of 15 are 1 and 15, and 3 and 5. So far my GCF, my greatest common factor, would be 5. I also noticed that they both have an x. So I have an x to the second and x to the first, so the smallest of the GCFs, the smallest of the variable x would be just x. Then I have y and y to the second, so the smaller of those two would be y. So now I'm going to divide each term by 5xy. So 10 divided by 5 would give me 2. I then have x squared divided by x to the first. So remember when we were multiplying with exponents, we added our exponents? So when we divide with our exponents, we're going to subtract them. So 2 minus 1 would give you x to the first. Then I have y to the first divided by y to the first. 1 minus 1 would give you 0, so my y's cancel there. So my first term would just be 2x. I then have negative 15 divided by 5, which would give me a negative 3. Then I have x to the first divided by x to the first. Remember, we're subtracting our exponents. 1 minus 1 would give you 0, so they cancel. Then I have y to the second divided by y to the first. 2 minus 1 is just 1, which is just y to the first. Again, you can distribute this out to check to make sure you factored it correctly. So if I distribute 5xy, I have 5 times 2, which is 10. x to the first times x to the first would give me x to the second. And I don't have any other y's here, so I just carry that y down. Then we have 5 times negative 3 is negative 15. I don't have another x to multiply by, so I just carry the x along. And then I have y to the first times y to the first. I'm adding my exponents, which is y to the second. All right, let's take a look at E next. In E, the invisible number in front of each of these terms is just 1. So I don't need to find the greatest common factor in terms of the numbers, but I do still want to find the greatest common factor of the variable because they all have a z. So remember, we take the lowest or the smallest exponent. So the smallest exponent of 10, 7, and 5 would be z to the 5th. So my greatest common factor for these three terms would be z to the 5th. So now I'm dividing each of these by z to the 5th. So when I divide, I'm subtracting my exponents. 10 minus 5 would give me z to the 5th. 7 minus 5 would give me z to the 2nd. This part can be a little tricky. So on letter D, we canceled out our variables when they had the same exponent because this is a 5 minus 5. Because I already had something there as a placeholder to still get back to that term. So I still need to put a minus 1 here because I would need to figure out, well, what am I multiplying z to the 5th by to get back to z to the 5th? So you still have to put a minus 1 because anything divided by itself is just 1. So we just didn't put a number 1 here, but you do need to put it here since you have no other terms. All right, that is the end of the greatest common factor video. All you need to submit is a picture of this work, and we will work on the rest in class. Have a great day, everybody.